sort of technical issues of trying to manage this remotely. But what I was hoping to do is show you a presentation which has got some videos and various different bits of stuff in it to keep everyone entertained. And then at the end of that, if we're interested or anyone's interested, we can do more of I don't know, an informal session where show you some of the back end stuff, show you some of the software we use and some of the calculations and things in case that's of use to anyone in their projects. So, you know, if there's anything as we're going through, just fire away questions in the chat, and we can also pick that up at the end. Of course, there'll be question time. Cool. So I'm going to share my screen and see if that works. How's that going? Can everyone see that? Or at least
not yet. There you go. Yes.
Okay, cool. So hopefully there's not a huge amount of lag on this, but let's see. So basically, yeah, we're talking about the U-build construction system. So it's a modular self-build system. We wanted it to be easy to make, enjoyable to inhabit, and quick to deconstruct at the end of its life. So this is a circular economy way of thinking about buildings. We don't want waste, and we want to use low embodied energy materials where we can. Although you can probably get a quick sense of this, like stage 1, you get some flat panels cut on a CNC machine. Stage 2, they're pushed together to form boxes. Stage 3, you build them up like Lego blocks, and we bolt them together, insulate them, and then put cladding on the outside. So I thought I'd start off again. Hopefully this works. If not, then it's just going to be 3 minutes of silence. But yeah, here's a quick video from one of our clients. They're actually a young couple, a pair of filmmakers, and they are building a tiny house.
Get that to me. That's how we set it all up.
Cool. So hopefully that worked. Otherwise, I said that was really painful.
Yes.
Um, yeah, cool. So basically, that's it's a work in progress. They are actually living in that house now. They came to us and they said, "Look, we've got a small budget. We want to build a tiny house. Can you help us?" And we sort of gave them the price, and they said, "We can't afford that." And so we part sponsored it, and they made a film for us. So yeah, it's fun little collaborations like that UBuild is doing. So here's another little quick video. It's sort of showing the showing the bits and pieces of the system. So the boxes that come apart, they're made of plywood panels. They connect together, and this is very kind of a basic illustration showing different parts of the system. We can look at it in more detail later. But yeah, so I think hopefully you get the idea now. It's kind of somewhere between Lego and IKEA and Meccano, and kind of a weird sort of sex child of all of those. So yeah, basically the reason that we've done this is because we come from an environmental background and we wanted to make buildings which are a bit different. So probably some of you have heard of that, about this, the kind of the donut economy or donut economics. And the kind of basic idea of this is that we live on a planet represented here in this green sort of blob. There's 9 planetary boundaries representing what the Earth is capable of doing, including sort of CO2 levels and the amount of vegetation, and I can't remember all 9. But then we've also got the sort of human needs, so represented by this inner circle. So if the sort of the limit of what the Earth's capable of is this outer red circle, the inner red circle is what we need as humanity to survive. So basic shelter, basic access to water, and various other things here, poverty. And so the issue is what we want to do to create a safe and just space for everyone is to create economy where everyone is within the donut, within that kind of green space. So we're not undershooting and we're not overshooting. But this is where we're at in 2020. So obviously we're failing on a number of different counts. We're not providing basic needs for everyone in the middle, but at the same time we're overshooting some of our planetary boundaries, and some of those are actually quite serious. So obviously this is where we need to be, and so we need a massive change in the way we're doing stuff. So rather than sort of doing less bad stuff, so our building uses 10% less carbon or something, that doesn't work when we're building more than 10% extra new houses each year. So we need to move to a do more good or a regenerative type of design. And so yeah, just to kind of jump into kind of where UBuild sits into all of this. So I'm a director of Studio Bark, which is an architecture practice some of you might have heard of. We set up about 6 or 7 years ago. We do a lot of work with, so we wanted, environmental architecture. So it wanted it to be environmental, but it to also be architecture, because at the time we felt that those two things weren't always connected. And we really like this sort of hands-on approach to building stuff, learning, working with universities. So we set up Studio Bark projects, which is a way of us learning, building, trying stuff. And then we realized that it was really hard to be architects and also be builders. And so we came up with UBuild, which was a way to try and make that process a bit simpler, so we weren't reinventing the wheel every time. And in the same time, trying to solve some of the problems that we saw on site through traditional construction. So we've already seen a few different things about pods and how they come together, but the reason that UBuild is set out as it is because we use off-the-shelf materials, so 18mm plywood, which in imperial size is 1220 by 2440. But what that means is that when we're using a CNC machine to cut it, we can actually cut the margins off and make something which is perfectly metric. So we can make boxes which are 400, 600, 150. These make most of our roof and floor slabs. We can actually do a brick bond pattern to make it expand more than that. We've got our standard wall boxes. Again, these are all on the kind of same grid, and then sort of smaller wall boxes. So with those kind of few elements, then you just put together the box quite simply, and then you put the walls together, and you can just about see the kind of bolt holes which we then use to attach everything. And the reason we think that this is a good idea is that if you're building a box, maybe you can pre-assemble those. Very unskilled people can do that, so it's quite an inclusive process. And then the bolts enable you to take the building apart again when you're finished. So, but as well as that, we're trying to work in such a way with small repeatable elements that can be split amongst big groups. So we can work with large numbers of people, community groups, and like mobilize a huge workforce where otherwise people are just kind of kept at arm's length because construction sites are dangerous, or they can be. But again, the kind of the main idea here, or the core driver, is that buildings should be adaptable. We shouldn't just be building things as one-off, which is then going to be sort of consigned to the scrap heap at the end of its life. So yeah, we're ready for the circular economy. We can configure, assemble, disassemble, and reconfigure, and we hope that our parts are part of a general kind of drive in this direction for more and more and less wasteful buildings. So I'm going to show you a few things that you build and things that we've already built. So this is Box House. This was actually featured on an episode of Grand Designs called Grand Designs The Street. And I can probably share the link if in the chat box later. This is another video showing how the boxes were built on site. A lot of this, unfortunately, is hidden by the scaffolding, but you can see that this was over the summer. I think it was 2017. The building going up in the background here, so all of the boxes. And we're going up to sort of 2.5 stories here. We think we can go up to 3 stories with it. Scaffolding coming down. We used locally sourced Western red cedar cladding on the outside. And so yeah, here's some of the shots of the finished building in context. So there was sort of one of 10 houses that were all built as part of the series. So you can see some shots of the interior, sort of some of the kind of raw spruce and some of it being treated. And we exposed all of the pipe work and everything like that. So we had this language of copper pipes for heating and black pipes for electrics going around the building. One nice feature was because of how insulated it was, we didn't actually need any radiators. We just needed the pipe that would usually connect a radiator. So yeah, a few more details, bits and pieces that we did as well. But yeah, this is kind of where we're at the moment. That was a kind of an example of what we could do. And now what we've developed from this is, if any of you use Grasshopper and Rhino, you'll be familiar with this. So this is basically a kind of a download of our collective brains. And what we're doing here is taking some very simple input geometry or base geometry on the left-hand side, like how, what is the physical volume of the building, and then all of this stuff on in the middle is turning that into a series of CNC cut drawings, so that we can print the building basically. Obviously, out of that, we also get all the schedules, all the drawings, the stuff that usually takes a long time in architecture, and we can produce very highly efficient use of materials. So that's another reason why we've gone boxy, because it just makes sense in terms of efficiency, which is ultimately good for cost and environment. So here's another example. This is a small pod which is being built, or has been built, by one of our clients. We've seen a massive rise in home working pods, so people needing space during COVID, and this is the kind of this is the kind of volume of parts being put together for this building in a garden. So this is one of the things that they created. Came up with this sort of herringbone or chevron cladding pattern, which has become like a bit of a signature. and you can see various different details, like how we've treated it and stuff to kind of make it stand out. But you can see that one of the things that's sort of unique about our system is we expose all the plywood on the inside. This is actually birch. And we think that that's really interesting because then it allows you to take panels off, get access for electricity, that kind of thing. Obviously, there's fire to think about, which I can talk about later. But we make our own windows and doors, just again using plywood, 3 layers of plywood sandwiched together amongst the window frame, or sorry, to clamp the window into position. So we can do quite a lot of stuff ourselves, just from being quite a small architectural team. We can sort of punch above our weight. So here's a few examples of other pods which have been built. So top left is this is for a Guardian company. So we're building a live-in pod inside one of their empty buildings. This one here was in Switzerland. It's for a kind of remote co-working space. And then this one here was some artist studios. So obviously there's a kind of similar language here, but we managed to build each one of these in about a day. So it's a really kind of quick get in and get out, and we can put them on wheels and stuff. So this is a community build in Leeds. So this was a group of artists who wanted to set up a gallery space and have 5 artist pods. So we worked with them over 2 days to build 5 pods. And this is the kind of parallel processing that I was talking about before. So you've got people who arrive on day 1 who've never done anything like this before, or maybe they're artists and they've had some experience with making stuff. But within the end of 2 days, and we've kind of set up a pop-up venue, which again is another really interesting thing for COVID, because what's happening is more and more people are sort of getting rid of their office spaces, and we've got all these weird dead commercial spaces. So this is an example for how we can improve that. So yeah, a few sort of shots. Here we're using recycled polycarbonate for the panels. That's quite interesting material. Again, shot of the team. Some other things we've been looking at. So this is augmented reality with a company called Hologram. And so this was, we were working with some students from the Bartlett to do this. I know I shouldn't mention the B word at Westminster, but so here we've got some sort of kind of on the fly instructions showing how someone in the future, maybe without such a clunky headset, could be taught to put together a building. So I thought that was quite interesting. And again, we can kind of go a bit bigger. This was at Grand Designs Live. We were building a big exhibition, and this was a kind of an idea showing how you could demonstrate the entire. It's a bit shaky, but demonstrate the entire kind of build process before someone kind of came, so you could sort of show them what it was going to be like. So yeah, still quite early technology, but very interesting. Very interesting. And then this is from planning application at our studios. So what we got good growth funding from the GLA to work with our landlords and develop a master plan for the car park, basically in our studios, and have this kind of like hanging gardens of Babylon made out of U-build. And so, oh yeah, I'll actually go to this one first, because that's maybe separate. But the first step in that was to create a pod which had a CNC machine in it, and then the CNC machine would then cut the remaining pods. And so this is not just a stock photo. This is actually the first pod which has been built, and the CNC machine, as of a couple of weeks ago, has just been commissioned. And yeah, the company's called Wick CNC, and that's going to be so I'm part of Wick CNC, or Studio Bark is part of that, and the landlord is part of the other. And so we're going to make our own little mini factory, which is quite exciting. And then this was we mentioned the kind of like hairy arrest sort of thing, and this was just our involvement in Extinction Rebellion stuff earlier. Well, this was in October 2019, but we've done some stuff in 2020 as well. Just showing how kind of modular buildings and architecture can be used to help occupy space. And so this was kind of quite key to them being able to keep the space in October. So yeah, so thank you for listening to that bit. I've probably rushed through that, but that's maybe because I've actually got quite a few other bits and pieces that we can talk about in more detail afterwards. So is that okay to have a pause for now and then maybe take some questions first of all?
Yeah, that would be great. That'd be great, Nick. We've got a couple of questions. One is floors in the U build. Are they? Pete was asking whether. Well, maybe Pete, you want to ask directly. Sorry.
Evening, Nick.
Hello.
Hi, Nick. I'm one of Will's staff. I'm curious as to how do you span the floors and roofs? Is it a sort of reciprocal structure where each of the modules lock together somehow? Because you don't get one long module anywhere, do you? If that makes sense.
It does make sense. So we've got two options for that. So the reciprocal structure you're talking about, we refer to it as a brick bond, and in the same way as we do the walls. So I should say that this system has been designed with a structural engineer called Structural Workshop, who we think are brilliant, and they took our very sort of simple idea of putting boxes together and made it into a kind of a viable thing. So the reason that we've got the vertical brick bond pattern is that one box bridges the gap between the others, and which is really good for kind of wind loading. And they've shown that we can do that for the floor and the roof up to a point. And beyond that, so for example, the CNC building that you saw there, which had quite long spans and heavy machinery, then we modify the boxes so that they can take a beam. So we can put either normal timber or engineered timber, and we have special boxes with little flanges which kind of sit on top of those. So that's how we deal with bigger spans.
Okay, thank you.
It's all good.
Thanks a lot. Look, I don't know whether Shakira, you want to ask the question, or shall I? I could go ahead if you don't want to chip in. But Shakira's asked. You obviously use a lot of wood. You've got plans to use other materials. I mean, is it to do with that it's sustainably sourced, or is it?
Yeah, I mean, I can show that in a minute. That's one of the things I wanted to talk through, the kind of bits and pieces we've been doing, is this idea of embodied energy, embodied carbon, and if you can, if you account for the CO2 that is absorbed by the tree in the building's lifetime, providing it's from a sustainably managed source, which ours is, then the building can lock away more CO2 than it takes to actually create it. And so this is what we're talking about, this idea of kind of regenerative architecture, or architecture which, when you built it, could actually improve the situation from how it currently is. Now, obviously, there's always, there's no silver bullet, because using a CNC machine takes some electricity, and human beings need buildings, but beyond that, so this is why we think that wood is the way forward, apart from the reusing existing buildings, because obviously that's pretty low energy as well. So that's why we use wood. In terms of other materials, yes, actually what's really interesting is there are some panels coming online which use agricultural waste. So there's a board, I think it's called Eco Board, imaginatively titled, which is like wheat and barley kind of leftovers, and when they sort of crush that together, it has a kind of a high strength. And there's also a company in Cambridge which has come up with like a bio-based glue which can join it all together. So we're getting very close to the point where we can have a CNC cut building which is 100% biodegradable, which we think is really exciting.
Yeah, absolutely. And Scott has had a question about the sourcing of the plywood. Is it always from one place? Have you?
No, the thing is, we can use what we've been trying to do is develop a system which isn't reliant on one particular manufacturer, because obviously that's risky. We've like focused on CNC technology, and a kind of like, you know, we're almost like a software platform in a way. Anything can go into it, providing it can be cut. And so we usually use a supplier called UPM Plywood, who make Weser spruce. So it comes from Finland, which obviously isn't brilliant because of the shipping. We can also use UK sourced sterling board, which is made in Scotland from Scottish timber, or smart ply, which is OSB as well, but that comes from Ireland. Now the issue is that in the UK we just don't really have either the forests or the infrastructure to make decent plywood. So, you know, some people might say that that's a reason why we shouldn't be doing it here. Maybe we should be focusing more in Scandinavia. But we think that we've basically calculated, even including the shipping, that it still works out carbon negative.
Mm-hmm. But have you made prototypes in sterling board?
Yes, we have.
Yeah.
And it looks okay. It's just quite busy. You know, the look is quite busy. You know, you can paint it obviously, but painting is, you know, it introduces another material which is not. It means that it's no longer a pure material. So, you know, there's always a trade-off, and we're still not quite sure what the perfect answer is, but we feel that when, you know, as new materials come on, then we're ready for them. You know.
Erin's got a question about he's asking about the fire rating of each block. I mean, I suppose units or something, but how do you fireproof?
Yeah, so you're right. I said I was going to touch on this one. So it depends really. What we have done, so for the Grand Designs house, we ended up using a sprinkler system because we felt that had two benefits. The alternative was using plaster, which makes the building non-circular economy. Like once it's in, it's waste if you take it apart. And it also is like toxic if it's not reused properly. If plaster gets into the kind of the waste stream and without being recycled, then it is actually sort of toxic to groundwater. Whereas the sprinkler system, albeit you know, requiring sort of energy to maintain, is just water. And then it has the other benefit of opening up the space, allowing kind of more sort of interesting architectural layouts, and is in some places is even considered safer anyway, because a plasterboard wall will only stop the building from burning quicker, but the sprinkler might actually put out the fire. So that's the approach that we took there. In terms of the actual fire rating for the wall itself, there are some options there. So this agricultural board that I was just talking about apparently is a natural sort of byproduct of the growing process. The straw or the wheat actually has some inherent fire protection. So that's one thing we're looking into. You can also get fire rated ecological medite board. Again, we're looking into that. So those are the different approaches really. Or for smaller buildings, then, you know, like garden pods, garden home offices, you don't need to fire rate them because there's so low risk of anyone being in there and the fire happening and them not being able to get out because they're so small. So
Sure.
yeah.
I wonder, have you made a model staircase that as part of your part of the system?
Yes, the one that you saw there wasn't actually modular, but I can go on. Maybe now's a good time for me to go on our Instagram page, and I can show you. Sorry, I've lost too many screens open. Cool. So yeah, this is. Oh, there you go. So this is a modular staircase that we designed for a company in London. They wanted to build. They had like a double height space, a commercial space, and they wanted a meeting room, mezzanine, and so we basically built a modular stair thing, and it was actually worked really well. We really liked it. And this is the floor that you see using that kind of interlocking sort of span. So there's not a continuous beam that goes all the way across there. And it's all been sort of signed off by the structural engineer. So we're quite confident with it as a way forward.
There's a question about loading here from Erin. I mean, I'm guessing that Erin, if you've got an engineer involved, they know it's going to take the load of a domestic property. So,
what was the question?
it's about loading. What's the maximum load the floor can carry?
Oh yeah, well, I mean, I think that's it. I mean, one of them is a CNC machine, so we can get commercial loading as well. So it's basically, it's not so much because timber buildings can take like big loads. The key is more the ground condition. And actually, one of the things that we've been working on, or we've been testing for our pods, is these kind of adjustable pads. So you've probably seen, like, you can get ground screws or little micro piles which go into the ground, and those are good, but they're really expensive. And so for our pods, we've been using these. They're basically like decking support feet, and each one can take a ton. And providing they're on some compacted hardcore, then we can just literally set those out underneath each one of our kind of beams, and for about sort of 30 quid plus some compacted gravel, then we've got a foundation system. So we think that, I mean, it's really interesting that what we like about working in the permitted development, like smaller than building control sort of sector, is that we can play around with all of these ideas where usually building control would just be a bit sniffy about it. And actually, one of the reasons why it's resilient to that anyway is, even if there was some tiny movement, then there's no plasterboard on the inside to crack. So that's why we can put these on the back of trailers and on kind of wheels and stuff. So I think it's just trying to think a little bit more about how this is just one solution. New build is just one solution, but it's trying to think about how buildings can be more adaptable and to their kind of to the problems with conventional construction.
How do you insulate these buildings?
So you can kind of see on here that basically we've got the open boxes. They face outwards, and then we fill them at the moment with sheet wall insulation. So we put 2 layers of sheet wall. One of the reasons that we've been using that is it's UK sourced. They can actually cut it to fit exactly, so that they just all arrive in pieces which go in. But we've also realized recently that they're not, that sheet wall is bad in another way, because sheep's production is, firstly, not plant-based, and also they do quite a lot of damage. But that's maybe a discussion I won't get into, because everyone's got a different view on it. But again, we're kind of agnostic to this. We can put wood fiber insulation in, we can put hemp fiber, anything really. But we like using the kind of the full width of the box so that we can use a kind of a low embodied energy material.
Right. So it's really nice to see that how these things work.
Yeah, this is another one. I mean, look, we've got one of the guys who works for us. He just loves making stock frame animations, and it's just so fun. So yeah, I don't know. There's something about it that I just really enjoy watching them. But cool.
So are you
Sorry, say again?
is you build going to be? Are you going to become a large house builder?
Well, I don't know. So basically, what we did at the start of this year is I sort of took a step back from Studio Bark, which is obviously still going on, still doing its thing. And we wanted to give UBuild the space and creative sort of freedom to be able to, you know, to really start growing on its own. And so we did that at the beginning of January, and obviously COVID happened. And so lots of the bigger projects that we had went on hold, and we ended up doing lots of kind of smaller pods like garden studios, tiny houses, guardian pods, commercial fit outs. This is just a kind of a selection, really. Drums, so we made some cajons, then helping out with sort of various other things like doing street parties for Black Lives Matter and loads of stuff like that. So one of the projects that we are working on, which I don't really have any video footage of, is a project called We Can Make. Oh, actually, no, maybe I do. Is there something? Yeah. So this is from a workshop day where we're at Knoll West Media Centre. So they're a community in Bristol who have decided that rather than having a big sort of Taylor Wimpey estate on the edge of their kind of, well, their sort of part of town, they've got funding to have a CNC machine and a small factory, and they're going to be building their own housing. So we're one of 5 companies who are working with them to deliver those, and this was just like a taster day. But this is really interesting because it's part of like a bigger finance initiative in Bristol to be developing more of these types of housing, led housing really. And so if we're going to be a big house builder, it's through enabling communities. Like I don't see us being like, you know, a Taylor Wimpey basher in the future, or at least not kind of replicating their business model anyway.
Well, no. Well, maybe Pete's got some words of advice with Walter Siegel on some of his in South London, some of that is self-build systems, and this seems to be more.
Nick, can I ask? Can you hear me?
Yes.
Nick, sorry, can I ask you? Is there a point where you can begin to think you can optimize what is basically assembled off-site and what gets delivered to the site? Because at the moment you could almost deliver a building, can't you? Bit like a trailer or a mobile home, or you could deliver the little boxes. I just wonder if you could begin to optimize that. If you were going to mass produce really on a scale, there might be a kind of unit that is idealized. I wonder.
Yeah, it's a really good point, and we've been trying to work this out ourselves. We've also been trying to work out what our business model should be. You know, should we just be licensing out our technology to other people? Should we be managing stuff on site? Should we be doing turnkey? And these are all things we're playing with at the moment. But the options we've got are, you know, look, this is a typical pod which can be delivered flat pack obviously there are some benefits in that we can put all of that in a small transit van, and then like put it in a small space in the client's shed or something. So obviously, like this used to be a stack of plywood, and now it takes up the same space as the original stack of plywood. So there are some benefits to that.
Yeah.
Oh, so am I getting? I think I'm getting some feedback. I don't know if everyone's getting that. But then there's some other. In fact, I think we posted one today, where we basically, when we arrived on site, we had already got the boxes built, and so we were there for 2 days, and we built 4 pods, and that enabled us to just get in and out really quickly. And the benefit in doing it this way, in pre-assembling the individual cassettes, is that we could do all of the quality assurance in the factory, make sure that we're not like sitting here just working out which part goes together, and a lot of this is to do with weight and transportation and logistics, and actually it's usually not the volume we've found is the problem, it's usually the weight that's the problem. So for us to pre-assemble this and put it in a 7.5 ton lorry actually works out just the same as if we had a 7.5 ton lorry with flat pack, so I think that that's the way, because we're never going to be competing, or we're not trying to compete with the people who are doing massive crane-based volumetric stuff. We're focusing on the
aluminium. It would be what? If it was all aluminium, it would be a fraction of the mass, wouldn't it?
Yeah, but if it was all aluminium, it would have a huge embodied energy to it, and so we've decided that that's not. Sorry, go on.
No, it's a trade-off, because it'd be much cheaper to transport and move and get around the world and so on, wouldn't it? It's a trade-off as everything.
Yeah, no, it's true. I think, so like there's definitely a place for metal, especially we think it's maybe for bigger structures, like stuff that we can't take on. But just with aluminium, because it does take so much energy to produce it in the first place, then we think maybe part of the issue is not just like the lifetime usage of it. It's the spike in carbon emissions produced now, given that we've only got like less than 10 years to be rapidly decarbonizing. So I'm not saying that we've necessarily found the only solution, but I think for everyone listening, for the students here, that these are really the things that we need to think about. It's I don't think it's that we're in a space where we can just start designing with whatever materials we want. We that's a constraint that we now have to kind of to bear as a profession.
Thank you, Nick. Thank you.
No, thanks a lot. Look, there's some other good student questions here, and then Scott, I'll come to yours in a second. Juan's asking, how are the boxes joined together?
So
are they with
joined
nuts and bolts?
No, so they're all joined together with so the original. I'm sorry, I keep unsharing my screen so that you can see me, and then sharing it again. But let's just do that. So basically the individual boxes are screwed together, and then once you've screwed the box, then the one box is bolted to the next box. So I don't know if I can find a slide that shows that. Yeah, so basically this section is screwed together, and then once it's like that, then that box bolts to the next one, and we use just either nuts and bolts or wing nuts to make it easy to undo. So there's no glue, glue anywhere.
That sort of relates to, well, there's a question, well, I'll come back to Scott's question which relates, but Michael's got a nice question, which is one is 2 questions. Has security come up as a question, and then he's interested in the window window and door mechanisms and the profiles.
Okay, so so when you say security, how do you mean by security?
I don't know, Michael. Do you want to clarify that? Where's Michael?
Yeah, can you hear me?
Yes.
Yes, we can. Yeah.
Thank you, Will. I was just really interested in the security. So obviously the way that PVC and aluminium doors are sort of put together with their profiles and how the glass fits in and how that actually adds to the security of the overall mechanism. What I was looking at is you said it was like 3 sheets of ply where the glass is inserted. Is there any other sort of security trim or anything that stops people from sort of just knocking out the back of the window, or is it? Am I thinking about it in? Yeah.
Yeah. Okay. So I think a completely fair thing to point out is that these are kind of early stage kit windows. So we don't have any multi-point locking or anything like that. So you know, this is, that said, because of the way that the plywood works, it's screwed. The screws are from the inside, and so you know, you just wouldn't be able from the outside, providing that it's locked in place, or you know the catches don't fail. You're not going to be able to get the window apart unless you kind of, I don't know, took a saw to it. You'd be much quicker smashing the glass or trying to bash the whole thing so that the catches broke. So really, then it just becomes like an ironmongery problem, you know,
Yeah.
or like trying to embed one of those kind of multi-point locking bars to the edge, which it's not to say we couldn't do that. It's just that we haven't really done it yet. And I should also add that for like a big building like the Grand Designs house, we didn't actually make the windows for those. We just bought those in as components. So you know, I don't think we're trying to say that we're solving absolutely everything. We're just trying to work towards that and, you know, work in a modular way. So if someone else comes up with a really good, you know, cheap and secure and airtight window, then we'll just drop it in. We'll, you know, because windows are a pain. They really are. They really are a pain in the ass.
Yeah, I can get that. That's fine. Thank you.
Yeah, good question, Michael. Yeah, Scott actually had a question about air tightness.
So is there a detailed question about it, or do you want me to just talk about it?
Yeah,
Maybe just talk about it.
Oh yeah, no, it's Scott here. I was with the obviously the boxes joining together and without any glues or gaskets. I was wondering if air tightness is an issue, you know, from inside outside.
Yeah, it's a very good question, and sorry again, one that I failed to mention. So part of the reason that we've built them in the way that we have is so that they can deal with air tightness. And so when we built our first pod, we got it pressure tested. So I'm a passive house designer by background, and so like we had this stuff kind of drummed into us about, you know, testing things and making sure that, you know, your air tightness is good, at least for the fabric anyway. Let's not get onto ventilation. But so basically the boxes on their own got down to 2 air changes, which for those of you who understand it, it's building control is around 10 and passive house is around 1 or 0.6. So that's just with the boxes alone. But then on the outside, we have a breather membrane. And the breather membrane is also an air tightness membrane. So that gets taped to the outside of the boxes. And by the time you've got the 2 layers, then you can be down to sort of passive house levels. So yeah, that's our solution.
Okay, thanks. Thank you.
Yeah. So how are we doing on questions? Are they, because
I think
I've also got.
Have you got something else to show?
Yeah, well, that's what I was going to say. I mean, it's kind of up to you really. You know, obviously we're getting towards 7. Oh wow, look at that kind of crazy effects in the background. So yeah, we're getting towards 7. I've got a few things I could show you. Can show you the Rhino model. Can show you some of the carbon calcs. I can show you, where we're going with our new website and all of that kind of stuff. So. How are you feeling? What's the kind of suggestion?
Well, it'd be nice to see what you're thinking about for the future. That'd be nice that'd be a nice point to end it. That'd be great.
Okay, cool. So, well, I'll just show you because I think that this is quite quick. So just this is like we've only got this back a couple of days ago. It's working with a company called Arena, and they're linked in with the University of East London. They've got EU funding to help small businesses develop kind of, solutions for embodied carbon and that kind of thing. There's a small b for Uber, which is not acceptable. So yeah, basically what we've shown with this kind of here we've got this kind of build up with this is a 150 ml box or a 300 ml box, and what we're showing here, so this is the global warming potential for the life cycle stages, which is basically cradle to gate, which is like from making the raw materials to it leaving our workshop, but not including the transportation and construction. But you see the raw energy or the kilograms of CO2 equivalent for the a standard U-build project is like it's like up around sort of 5,000 kilograms or more with the 300 ml build up. But if we take into account the biogenic carbon storage or the carbon stored when the timber was grown, then the figures are negative. So even by the time we've like accounted for the transportation and construction, we've probably got a building which is using less CO2, or in net terms is sequestering more CO2 than it's using. So it's quite an interesting proposition, and obviously the building itself is going to use energy in its lifetime, and that's the other part of the puzzle. But yeah, so that's one thing we're looking at. So trying to build that into all of our new product offerings, so that people can see, like CO2 warning, like you have on Oatly, and then yeah. So this was just some different U value build-ups, which I can share with anyone if they want. Maybe I won't go through them now at 7 o'clock at night, but we've done all these different sort of tests of like building regulations, building and versus R1. And then finally, like you said, just to give you a flavor of where we're going with the website. We at the moment it's quite conceptual, and we're basically sort of splitting it up into a few kind of new sections. Design your own interiors, homes, and then maybe another one, community scale. And then we're going to be showing a number of different pods and different like things that people can go on there, see the different sizes, customize them, buy them, and yeah, like various other things sort of to do with that. So I think what we're hoping is, like, or at least what's already happened is that we've had like loads and loads of inquiries from people doing stuff, and if we can get it to a point where, yeah, okay, we can make loads of random things, but we've also got a series of sort of template designs as well, then we can be sort of selling the licenses to those to people around the world. And we've already been working with a company in Australia, of all places, just to prove that we can work remotely. So this is the sort of the down under pod, which yeah, they basically they've been cutting that out at their factory, and yeah, we just want to work on cool projects like everywhere really, that make sense, and we don't want to ship stuff. So yeah, maybe that's enough of a ramble. Oh, and then finally just more stuff with with protest architecture and supporting like anyone who's got a political movement to kind of create opportunities for them to take space and just be disruptive, really. So yeah, maybe that's enough of the. That's taken us to exactly 7 o'clock.
Well, thank you so much, Nick. That was great. And I think some of the students would like to know the technical. Some of the stuff, some of the value stuff, would be nice if you wouldn't be sharing that at some point further on. That would be terrific.
Lovely.
And yes. Sorry, just my connection is terrible.
No, that's okay. So I just thought one thing. I don't know if I can. Can I write a link in the chat or something?
I think you can, yeah.
Yeah. So I was just going to say if anyone wanted to thank us, then if you go on our Instagram and follow UBuild, then we'd be very grateful. But
Great.
Good
idea.
Cool.
Well, thanks so much. Really inspiring. That's great. Really enjoyable.
Amazing. Thank you so much. The one thing I didn't say, maybe I should have said it, is UBuild is a not-for-profit. So that was the other thing we did when we set it up. We wanted to make it so that there aren't any shareholders, and we have to invest the profits back into it. So So if anyone's got any worthwhile causes that they know of that they think UBuild could help with, then let us know. We'll see if we can help.
Well, there's a community building project that another member of staff is working on, and so I might put her in touch if that's okay.
Definitely, yeah.
Great. Thanks again, Nick. That's fantastic.
Lovely. All right. Thanks so much.
We'll get you in the building soon when we open up.
Yeah, I'd love that. Do invite me when it's possible, because I'd love to come and meet everyone.
Yeah, brilliant. Cheers. Thank you.
Thanks, guys.
Thanks, bye. You get lots of thanks now.